So here we go with 3.1, all the questions from the papers, and it's going to be the foundation part. It's quite a bit to get through, so I'm going to try and get through this as quick as I can. Here's the foundation formula sheet. So there's a little bit less, and we got less prefixes here. So the first question, a group of students set up the circuit below to investigate how current in the lamp changes with the voltage across it. So name component Y. Well, Y is variable resistor. State the purpose of Y is to alter or change the resistance in the circuit. So this thing allows, if it's set to maximum, it's not going to allow any current to flow. So that's, but if it's set to minimum, then it's going to allow all the current to flow. Describe how a set of results can be obtained for 2 marks. We don't want to go into too much detail here, but basically what I just said, you want to set the VR to maximum. And you want to measure the voltage with a voltmeter and the current with an ammeter to get a series of results. What I should have said there, you're going to measure the voltage in parallel. Okay, ignore this brown bulb. That's for a later question. So that's why the voltmeter is in parallel there. And the ammeter has got to be in series with it. So with the component it's measuring. So just anywhere in that circuit, that ammeter could be anywhere. And then adjust to the VR to obtain a range of results. So I probably would have, well, I don't know, for 2 marks, they probably would have given me that. They connect an identical lamp in series, so that's next to it, okay? Between the cell and the ammeter. State how this affects the resistance. Well, those bulbs are going to get dimmer because it's in series, so it's going to increase the resistance. Therefore, the current is going to decrease. That's why they get dimmer. So if resistance increases, current decreases. How does this affect the reading on the voltmeter? Well, the mark scheme says decrease, so I'm guessing that it's only across this one by here, because as we know, the current gets split in series. The voltage gets split in series, so it's going to be the same voltage, but if I put another bulb here, it's going to get split across them. So I'm guessing if it's just across one, it's going to decrease. Although, the way they've shown it, if you go and put a bulb in here, the voltage is going to read exactly the same because you're measuring the voltage of the 2 bulbs there. So a bit of ambiguity there on the part of these, but state how this affects readings of the voltmeter. This is only from the sample paper anyway, so had enough students said stays the same there, then they would have had to give the mark, because it doesn't really state how this affects the reading of the voltmeter. They connect the ammeter between the cell and the ammeter. Yeah, it's a tough one, but over that bulb, it's going to decrease the voltage because it gets split across the 2 bulbs, so it's going to decrease the reading. Went off on a tangent there. Then they connect an identical lamp in parallel. So add this to the diagram above. So that's what the brown thing is there. Okay, the brown line, that lovely straight line, and then I've put a bulb in parallel. It's opposite it. And then I got a series of questions then. State how this affects the resistance. Well, it's going to decrease. The more bulbs I add in parallel, the less and less it gets, because if you're higher, you got the 1 over R equals 1 over R1 plus 1 over R2. And we all know it comes out to less then. If it was in series, it would increase the resistance, but because it's in parallel, it decreases the resistance. And then state how this affects the current in the circuit. Well, if the resistance decreases, then the current is going to increase. It's that relationship. As one goes up, the other goes down. State how this affects the current in the first lamp. The current in the first lamp is the same brightness. Okay, they don't get brighter every time you add a bulb, but they don't get dimmer either. So it means it's the same current. And then this was from foundation paper, I think 2017. In a class, a group of students set up this series circuit. Use the equation R equals R1 plus R2. So here's an instance we can see where resistance, if they're in parallel, it's going to increase. So you've got 2 plus 6 there. And that's the equation. That's in the front of your formula sheet anyway. You can see it there. Like I said, if you're higher, you're going to have another one as well. Use the equation from page 2 to calculate the current from from A1. So there's A1. So what have I got? I've got a voltage of 12. I can get that from my diagram. I've got a resistance, I just calculated, of 8. So I'm looking for current. Well, the only equation that satisfies that is I equals V over R. You can get that there. There is the top one, look. And lucky enough, it's already arranged for us, I equals V over R, but sometimes we need to rearrange it because we might have to look for another one. And the way we do that is because V is already on the top of R, V stays at the top and we put it in this triangle. So then fill in the blanks, voltage is 12, resistance is 8, I come up with 1.5 amps. State the current reading on ammeter 2. Bit of a trick question there, it's exactly the same because we know that current stays the same in a series circuit. Wherever you measure it, even if you stuck it in between them, it's going to measure the same, 1.5. Complete the sentences. So the 6 ohm resistor now is removed from the circuit and it's added in parallel. Ooh, exciting. Complete the sentences by underlining. So the total resistance now of the circuit is going to decrease. If it's in parallel, it's going to decrease, not increase. And then the current readings on A1 is going to increase. Okay, because as current goes down, as resistance goes down, current goes up. Lovely. Next question. Students are investigating current voltage characteristic of a filament lamp. So that's just a bulb. An incomplete diagram of the circuit was shown, so it didn't give you, so we didn't have the ammeter or the voltmeter, so you needed to add these for 2 marks to that. So an ammeter in series, voltmeter in parallel across the bulb there, across the filament lamp. Now for 3 marks, describe how the circuit can be obtained to get a series of results. Well, set the VR to maximum setting, VR meaning variable resistor. Measure the voltage with a voltmeter in parallel, I should have put, and current with an ammeter in series. Adjust the variable resistor to obtain a range of current and voltage readings, and then you would get a table like this. Now it's worth noting that this is your independent variable because you are choosing at which setting you want your voltage, and then you're taking your current dependent on your voltage. So this is your dependent. So if you weren't given the axes in the exam, voltage is going to go on the bottom, current is going to go on the side. But in this case, I'm going to leave it out because I'm probably going to need it. They've given it to you and a lovely little scale, look. So they've already given you the scale as well. So that's all you've got to do for 3 marks is just plot the results. And you've got to be crazy to get this wrong. So just watch out here. So every small square, every box has got 10 squares, every small square, 0.20. So it's worth 0.02 now. Okay, so that's what you've got to be careful of. So 1 box up from 0.2 is going to be 0.22, 0.24, 0.26, 0.28, and then 0.3. So you've just got to be careful to get that scale right. That's the only way you can bump up your scale. If you get it right, you've got 3 marks with that nice little curve as well, filament lamp curve. And then they give you an equation there to use. So calculate resistance across the lamp when it's 3 volts. So you can see my pink line at 3 volts, I've drawn it up and across, and it's 0.6. So my current is 0.6, my voltage is 3, because it's already given me. What's my resistance? Well, I just use this. But again, if they didn't give it to me to calculate resistance, I'm going to use VIR, this one, and then I'm going to rearrange that. And then it comes out to be 5 ohms. Student concludes that the resistance of the lamp increases as voltage increases. Explain how this data supports your conclusions. So as voltage increases, current also increases at a decreasing rate. Okay, this decreasing rate is due to the resistance increasing. So it's just asking you there to describe the trend of that graph. Let's check these up. 9 minutes. I might be able to do this in 2 videos. The boxes on the left show, oh, yeah, I'm not even going to read that. Come on, it's a matchy, isn't it? So there's your switch. So there's your fuse right down the bottom. There's your light emitting diode because it's got little arrows coming off it. Your thermistor looks like an ice hockey stick. Thermistor, temperature, ice. That's how I remember it. Your switch, your open switch, your LDR. So light dependent resistor. So light coming in there. That's the two possible. These two are your possible ones to get confused with. And then it's got this good old Reese. Correctly uses the circuit shown below to investigate the behavior of a thermistor. He takes a photo. So what's happening here is you've got your thermistor, and they're going to in this beaker of varying temperatures of water there. And that's what they're going to do. He places thermistor in the beaker of hot water to start the experiment. So I reckon we're going to have a series of results, range of results coming up now. Complete the circuit diagram. So I've not stuck a voltmeter in because there's not a voltmeter there. There's only a ammeter. That's the only thing they've got there. Just looking now. Thermistor. There. Did it show the circuit? No. How do I get that then? What was it worth? 2 marks. Oh, right. So the lines hadn't been drawn on this one. I was just wondering where the 2 marks were there. So I needed to connect them. So there's no voltmeter required on this one because they're just using the results from the thermistor. So there's the temperature of the water. There's the current. They're going to measure the current. That's just like a variable resistor, only they're using the temperature of water to change it. And then you're going to plot those results, and that's what they're going to look like. 3 marks. So you can see here that it's a nice curve going upwards. That's what a thermistor curve looks like. And then it's going to ask you to describe the relationship between the temperature and thermistor. Well, as temperature increases, the current increases at an increasing rate. So if I just pull that back up here, so it's covering more temperature here for less current than it is there. So you can see for the amount of current, for the amount of temperature that I put in, the current shoots up, whereas the amount of temperature I put in here, it doesn't really go up as much. So that's how I know it's an increasing rate. Resets up the following circuit. So I got 2 lamps and a thermistor. Explain how this circuit can be used to indicate changes in the temperature. Well, the more resistance you're going to get from this, the dimmer these bulbs are going to become, and that's how you can gauge that. So changing the temperature will change the resistance. So increasing the temperature should decrease resistance of bulb will be brighter. So increasing the temp will decrease resistance, and it's the same with a light dependent resistor as well. As the light intensity increases, the resistance decreases. You've got that inverse relationship there. Lamp B breaks. Explain what happens. Well, because it's a series circuit, nothing works then because the circuit is broken. So circuit breaks, so all lamps go off.